Natanz, Iran, 2025. At the center of all this conflict sits the most protected nuclear facility on Earth. Right now, America and its allies are targeting Iran's nuclear program. But to understand what they're actually trying to destroy, I'm going to show you inside this underground bunker. At 90,000 rotations per minute, these machines can turn natural uranium inside Natanz into nuclear weapons material. But here's the paradox. The same precision that makes them deadly also makes them incredibly fragile. In 2025, 15,000 of these machines destroyed themselves in a single night. I've modeled this facility to take you 50 minutes underground and show you exactly what's happening in this conflict. To understand how 15,000 nuclear machines destroyed themselves, I'm taking you on 3 journeys. The fortress inside the world's most protected nuclear bunker that took Iran 20 years to build. The physics, how uranium becomes weapons grade, and why precision creates catastrophic vulnerability. The failure, how the most advanced nuclear facility defeated itself in a single night. By the end, you'll understand what's really at stake in this conflict and why nuclear technology is both humanity's greatest achievement and its most fragile creation. In 2002, satellite images revealed something extraordinary. Iran was building the bunker, building a massive underground complex at Natanz. But not until now has anyone shown you what they actually built. We start at ground level, administrative buildings. Nothing special. But beneath your feet lies an engineering marvel that took 20 years to perfect. First, 22 m of earth, then 2.5 meter of reinforced concrete. The roof can withstand nuclear attack. At 8 m down, the first level, but we're going deeper, 50 meter underground. Welcome to what was the most protected nuclear facility on Earth. 2 caverns, each the size of 7 football fields, housing $3 billion worth of nuclear technology. This isn't just a nuclear facility. It's an underground factory that scale cost around 20 years and an estimated $50 billion to complete. To understand the scale, if you walk the perimeter of one hall, you'd cover nearly a mile. Iran moved 2 million cubic meters of earth. At peak operation, this single facility could have produced enough weapons-grade uranium for 15 nuclear bombs per year. The halls stretch 190 meters long, 170 meters wide with 16-meter high ceilings. But here's what made it extraordinary. Every detail was engineered to protect the most delicate machines ever built. The floor could support 15,000 spinning machines without vibration. The air filtration prevented a single dust particle from contaminating the enrichment process. Iran, the centrifuge halls, spent billions creating impenetrable protection. Multiple electrical grids, emergency generators, blast-resistant everything. The facility was designed to survive a nuclear attack. At peak operation, over 1,000 Iranian nuclear engineers worked in shifts to monitor these systems. Each completed centrifuge cost $200,000, more than most people's houses. This facility represents 20 years of Iran's most advanced engineering talent, working in absolute secrecy. But they made one critical miscalculation. They built a fortress to protect machines that could destroy themselves. The same precision that makes nuclear enrichment possible also makes it incredibly vulnerable. Step inside the main enrichment hall. This is what $3 billion in nuclear technology looks like. How uranium becomes weapons-grade row after row of centrifuge machines in perfect formation. Each machine 3 m tall, carbon fiber and steel, spinning uranium gas faster than jet engines. At peak operation, 15,000 machines ran simultaneously. The precision required is beyond anything in the normal industry. Here's how you transform ordinary uranium into weapons material. Natural uranium is only 0.7% Phi U-235. For weapons, you need 90%. Each centrifuge spins uranium hexafluoride gas at exactly 90,000 RPM. Centrifugal forces separates isotopes by atomic weight. Heavier U-238 pushed outward, lighter U-235 collected at the center. The machines work in cascades. 164 centrifuges connected by precision versus fragility pipes. One cascade 0.7% to 3.5%. Multiple cascades reach 20%, then 60%. Iran has enough 60% enriched uranium to make 15 nuclear weapons. The final step to 90% takes just weeks. But here's what nuclear engineers know and the public doesn't. Precision creates catastrophic vulnerability. At 90,000 RPM, tolerance for error is smaller than human hair. A momentary power fluctuation doesn't just stop a centrifuge. It tears the machine apart. The rotor becomes a 200 lb projectile spinning out of the power failure control. Here's the engineering nightmare. Imagine a Formula One engine spinning at maximum RPM. Now imagine the throttle cable snaps. The engine doesn't gradually slow down. It destroys itself instantly. Multiply that by 15,000 machines, each containing months of enriched uranium, all connected in a delicate network of pipes and sensors. Every centrifuge requires perfect electrical control, precise voltage, exact frequency, constant power. Without it, these machines don't gracefully shut down. They self-destruct in seconds, and one failure can trigger a cascade across the entire facility. The most sophisticated nuclear protection system collapse in a single night ever built had one fatal weakness. Everything underground depended on electrical infrastructure sitting on the surface. Iran had backups, emergency generators, redundant systems. But what happens when precise engineering meets the chaos of the real world? On June 13, 2025, Iran's electrical infrastructure experienced simultaneous failures. Not the bunkers themselves, the power systems that kept 15,000 machines spinning in perfect harmony. What happened next revealed the fundamental paradox of nuclear technology. The more sophisticated the system, the more ways it can fail catastrophically. The morning after, Iranian engineers faced an impossible cleanup. Uranium hexafluoride gas had leaked from damaged centrifuges. Aftermath contamination twisted metal that once spun at jet engine speeds now blocked access corridors. Some holes were too contaminated to enter for weeks. The facility that took 20 years to build was reduced to an underground scrapyard in a single night. 20 years of nuclear development, billions in equipment undone by the same precision that made it possible. This is how a nuclear technology actually works, and why it's both humanity's greatest achievement and its most fragile creation. The same precision that can power cities or destroy them also makes these systems vulnerable in ways their builders never imagined. Understanding this paradox helps us understand the technology that shapes our world. And right now, as the U.S. considers 802 lessons legacy military action against Iran's nuclear program, this technical reality becomes more important than ever, because in nuclear physics, precision and vulnerability are two sides of the same coin. If you enjoyed these videos and want to support the channel, be sure to check out the Patreon. It really does mean a lot.